I recently had to order an assortment of items for a mobile video editing kit I'm putting together. So I've got a little keyboard that I'm going to configure for my most commonly used video editing shortcuts, little programmable macro keyboard. I've got a docking station that's got various useful inputs and outputs, a rather fetchingly purple Logitech mouse, and some cables. And I bought these from Aliexpress because that just happened to be the place I could get them all together. As it often goes on Aliexpress, you sometimes find yourself a little bit short of some threshold for free shipping. And so you can either pay for the shipping or you can just select another random item, add it to the cart, and then you get free shipping and you get a thing for the same price as you would have paid for shipping. I did that recently, and here are two things that I got just to take me up to the free shipping level on two different orders. These are both fun little electronic kits, and I think today we're going to assemble one of them. So let's have a look at what we've got. This first one is like a little electronic die or a spin the bottle type of game. So it's got a collection of coloured LEDs there. Let's find this circuit board and then we'll make sense of it. So yeah, you assemble the LEDs onto the circuit board. It's got a push button in the middle, little battery compartment that goes underneath. You press the button, the LEDs cycle round that way, up. The LEDs cycle round rapidly, and I think when you release the button, one of them will remain lit. And so, useful way of picking, you know, like I say, spin the bottle type of thing, or perhaps if you want to use it as a D10. And that's all the components for that. And it's got a little plastic case to go with it as well. So it is actually intended to be used as a small dice-like appliance. So that's that one. And then this one is similar kind of electronics actually. So, but it's a bit more complex. So what this one does is it's got a grid of 9 by 9 red LEDs. One of these LEDs will be lit at once, so you get a little dot that moves along. And one of the little dials on here increases and decreases the X speed of the dot moving. The other one does the Y speed, so it kind of does a scan pattern. And you can make it, I think you can turn it up fast enough that you just see scan lines. So that's that. Both using decade counters, I think. So both using the same little integrated circuit, which is a decoded decade counter, basically a little chip that when you give it a clock pulse will go high on one of 10 pins in succession. A bit like a shift register, but not. So we're going to assemble one of these today. Which one do you think we should do? This one's definitely simpler. I think we'll start with the simple one. Maybe we'll get round to the more complex one in the same video. Who knows, we might do both. This one does not have any instruction leaflet, although all of the components are labelled on the silk screen on the board, so we can probably just work it out from, well, some of them only fit in one place. The four integrated circuits, these are 555 timers, these are decade counters. Those two are identical, so we can't mix them up. I think there's only one type of transistor here. There's only one type of LED. There are three different sorts of resistor, but their values are marked on the board. So we could probably assemble that without instructions, but I will go and see if I can find some. That QR code is not a link, it's just that model number, CHA81001. But if I search that, I can probably find instructions. Interestingly, there are instructions for this one. There's a little, presume that's a QC sticker. So there are instructions for this one, well, kind of. That doesn't really tell me anything I couldn't glean from looking at the board. I assume these QR codes go to some version of instructions. There's a circuit diagram there. So yeah, you've got this decade counter, you've got a 555 timer, which is the other little integrated circuit. Interestingly, socketed chips. That's a quality I didn't expect. Oh yes, in fact, there is a exhortation here to download an instruction video. I'm not sure I really want to try to follow along a video, so I will probably just take notes. I mean, how hard can it be? Okay, let's do some assembly. So I've got everything I need here. I've got my soldering iron with the sponge pad moistened. I've got a new tip in there, so I'll have to tin that first. Got some solder here, old school lead-based solder, so I won't be chewing on it. My little precision cutters, a solder sucker pump in case I make a mistake, lenses to read the tiny lettering on the stuff, flux if I need it. It is flux cord solder, so I might not need it, and all of the components. So I had a look and followed that QR code link that was on there, and it goes to a Google Drive that I really don't like it when they do that, because if that suddenly disappears, then there are no instructions. We can, I think, more or less divine the instructions from this circuit board and the circuit diagram. Interestingly, it shows two switches there, and I thought for a moment that was just because this little tactile switch is double pole, but it's not. It's because there's also this, which is a motion, which is like a tilt switch. So I think this thing works if you press the button or if you shake it. That's fun, if we get there. So anyway, the documents on that Google Drive was a video, which I didn't even bother watching, and this document, which is kind of like a expanded version of that, but it's got some quite lucid diagrams on the back here about assembly, order and instructions, and color codes for resistors and assembly of the case and such. So we'll follow these instructions and see how far we get. There's no English writing on here, so I'm just going by the diagrams. So we want first to populate the resistors. Typically when you're soldering on through-hole components, which these are components with leads that go through the printed circuit board, they're not surface mount. So typically when you're soldering a board with through-hole components such as these, you do the flattest components first, so the smallest ones, or the ones that lay flattest to the board first. So that's the resistors, and if there were any, diodes. So two 470k resistors, and these go in next to the 8 position here. They go into these two holes here. There's to that. Just splay those pins out on the underside to stop those falling out. Okay, then we are to put the 470 ohm resistor into that position up there. Okay, that leaves then the 10k resistor in the middle, which is there. Okay, that's resistors populated, or at least in place. Let's get those soldered in. So, soldering iron on to 380, I think we'll go for 380 Celsius. Should be more than enough for lead solder. Okay, that's up to temperature. It's nice and quick. Just need to tin. Wow. Okay. Why don't we put a bit of flux on there? That's really rather resistant to tinning. I've just managed to get a little bit of solder on my skin there. I can have a little burn there. That's really interesting. That's just not tinning at all. Let's try a bit more flux. I need to get it on a heat resistant surface. Not a huge big deal if the solder doesn't actually stick to the soldering iron. I think it is preferable to have the bit tinned, but if it's sticking to the components is the thing. So I'm not sure whether this liquid flux is the best thing either, but let's see if we can tin it in a bit of flux here. Turn it up a little bit. 400. Okay. Turn that back down to 380. Let's just try soldering one of these pads. We are heating the pad and the component leg, and then solder goes onto those two things there. So that's the plan, is to try to do that. My goodness, that's not really working very well at all there. Just flow that. There we go. That joint looks a bit dry. Okay, let's try some different flux. So this is like a paste flux. Let's just reflow that joint there with a bit of flux on it. Not my best ever solder joint, but the whole point of getting these actually is to get a bit of practice in, because I've got another electronic project in planning, and that will require a fair old bit of soldering. Oh, come on. I've managed to bridge those two now. That was stupid. Right. That's getting better. Right, I think I will add a little bit of flux to these because it's just helping. Okay. That one. That one. And then this last resistor over here. That's the resistors soldered in. And now I can just snip off those stray legs. What's next? Next, that little capacitor, little ceramic capacitor, goes in. Well, there's only one place it can go, so let's see if we can find it. It's that position there. Ceramic capacitors don't have a polarity, they don't have a plus and minus orientation. Electrolytic capacitors, which we'll come to later, do. So we've got to be a bit careful with those, especially as if you get them the wrong way around, they go boom. Let's get this in place then. So let's see if we can do this a bit more elegantly than before. So heat the pad. Probably should have got one of those little arm things to keep everything together. Yeah. Right, that's the little capacitor. It's at times like this I'm glad that there's no close-up camera on me here, because I don't think these are the best solder joints in the world. Next, step 3, is this tilt switch. So, does it have a particular... It doesn't have any polarity, I don't think. But that shows it that way round, so we'll do it that way round. Bend these pins very close to the body of the components, which is not always great. Okay, there's that. It doesn't feel like my soldering iron is hot enough. Let's try it a bit higher. Let's go for 430 or something. It honestly feels like the temperature of this soldering iron is fluctuating wildly. I wonder if it is, or if it's just bad workman blame tools. Okay. Nextly, transistor. There is only one transistor. I was going to say something's rattling, but of course it's the tilt switch. It's got a little mechanical actuator in there. It's not a mercury tilt switch. It's probably just got a ball bearing in there or something. So I thought I'd left a component loose for a moment, but no. Right, transistor into there. This we've got to be a little bit more gentle with, because this is a more heat sensitive component than some of the other things. So a little bit of flux. So we heat the pad and the leg of the component ideally, then flow a bit of solder onto both. There we go. Well, that's a bit messy. Just touch that one up. Some random loose ball of solder in there. Let's just get rid of that. Okay, nextly, well, surely we do the sockets before the LEDs, because the LEDs stick up further than the sockets for the... Okay, well, it says LEDs next. I don't think that's a very logical order, but we'll follow the instructions because we're testing... No, it's actually switch next. So it's the tactile switch next. Where's that gone? There it is. These things have little kinks in the pins, and it can make them quite tricky to get through the holes. There we go. Yeah. Just don't seem to be getting the temperature on this soldering iron. Just don't seem to be transferring the heat to the components. Well, not proud of those, but we're getting somewhere. Right, what's next? LEDs, it says. Now that's weird because they stick up further than some of the other things, but anyway, we will press on. Okay, so now the LEDs, the order they've got them in on the board looks a bit messy to me, but I don't think it matters where they go. But we've only got 2 blues and we've got 2 yellows, and then we've got 3 each of yellow, of green and red. So I'm going to arrange them slightly differently. Yeah, I don't think there's any specificity to these. There's no resistors per LED, so I don't think it can matter where they go. 10 holes and 4 different colours. There's no way to do it perfectly. Okay. Yeah, I think that looks... I think my arrangement looks different to theirs, at least. Right. Now we should find that it will sit flat now, because those LEDs will hold it in place. So here we go. It's just not... Sometimes it's just not melting the solder. It's almost like it's cycling up and down. I wonder if there's a problem with the thermostat in this soldering iron. Yeah, see, look, then it's fine. Do you know what? I'm going to power this down and put the old soldering bit in there. I wonder if I've got the wrong bit or something in there. So I'm going to let that cool down. And we'll come back in a minute. Right, back again with a different tip on the soldering iron, which, interestingly, I can... Yeah, that's just working much better. I wonder if the other one just didn't have enough thermal mass to do the job. Okay, let's see if it's me or if it's the tools. Here we go. I'll solder one that I haven't I haven't touched so far. So we'll just put that up against the... It's just night and day, that is. So I may go back and reflow some of those ones I did earlier. But yeah, this is just plain sailing now. So in this particular case, it wasn't me. Okay, right. I'll snip off all of those now. Okay, I'm just going to have a little look over the board actually and just see if there are any... Yeah, there's quite a few joints I would like to touch up there. So these switch ones I think will do. Just so much better with this soldering iron as it is now. Yeah, that's all those little resistors. Okay. The tilt switch. Okay. What is next? Next, the batteries? Really? Where did I miss a step here where they soldered on the sockets? No. No, next is the sockets. Right. So, these integrated circuits have a little notch at one end, indicating where pin 1 is. The sockets also have a little notch at one end. Obviously, it doesn't matter so much for the sockets, but we do want to make it so that it's possible to identify, once the socket's in there, where the chip's got to go. So it makes sense to put the sockets the right way around, even though it doesn't matter in electrical terms if you don't. Yeah, see now that's lower than the LEDs. So there is a slight risk of that falling out when I'm trying to solder it, and there's not enough pin there to really bend over and hold it in place. So I think what I'll try to do there is I'll just solder one corner and the opposite corner, and then just check it's flush. Yeah, it is. If it wasn't, I could then put pressure on while I melt the solder and push it through. But there we go. So let's just do all of those then. Okay. Not bad. The other one looks good. And again, we'll just do one corner. And the opposite corner. Check for flush. It's good. And then away we go. Now this is interesting because I can see two unpopulated capacitor places. Oh, I have got two capacitors. There we go. So those must be next, surely. Where the capacitors get? Oh no, I missed step 2. There we go. Oh, well, whatever. I bet you've been yelling at me at the screen. So yeah, all of the capacitors go in. Okay, so there's 4.7 microfarads. Not that one, even though they're more or less the same size. Okay, that's 4.7 microfarads, and there's a marking where the negative is there, and there's a marking on the hole, so we can't go wrong. Okay, and that goes into there. And then 10 microfarads, and again there's a line marking the negative side and a marking for it on the hole. And there we go. Now the battery case just says to solder it onto the back of the board. Not really sure I want to do that, but we could just go over the side. There's plenty of slack on the cable. Yeah, I don't really like the idea. It's a shame it doesn't go through a hole and come surface the other side and then go back into this. You know, they could have drilled a couple of little extra strain relief holes here so the cable goes through, comes back, and then into there to be soldered. But it isn't. Let me just see what the tolerances are like on this. It does look like they don't have the wire going over the edge. It does go straight into the back. Okay, well, okay, we'll do as we're told. Well, so what I'll do with this is, well, trouble is once that's in there, there's not very much room for solder, but we'll do the best we can. Okay, that's one of them. Oh, it's burnt some insulation. That's not nice. Yeah, see, that didn't really work, did it? Not liking that. So do you know what I'm going to do? I'm going to do it the way I thought it should be done, which is to put it round this side, stick it through, and actually solder it to the pad. This might cause us a problem later on because I think it means the wire will have to tuck over the edge of the circuit board. So I might need to just possibly even trim out a little piece of the circuit board or something, but there's no track there, so it's possible to do that. But yeah, that's just not a good design, that little bit. These are through-hole components, so you don't solder them on the wrong side of the board, generally. Okay, there we go, that's the battery holder. So I'm just going to go and clean up all this flux now. A bit of alcohol and a little brush, and back in a moment. I think that's all the soldering done though, so I can turn that off. All right, let's just press on. So now we've got to install the chips. We have gone out of sequence a little bit here. So, anti-static precautions when handling integrated circuits. I'm just going to earth myself against something that I know is connected to earth. You may know that as grounded. I'm always grounded. I'm not always earthed. They need bending in a little bit, actually. So I'm just going to gently ease those pins in a little bit. Make sure the notch is at the right end. And that's one. So that's the decade counter. And this is the 555 timer. 555 timer, fantastic little piece of electronics, really. Very, very common integrated circuit. It's an oscillator, and it's quite often called a clock, but it's like an oscillator and latch and multi-purpose oscillator, multi-vibrator chip. Very clever and ubiquitous. Okay, right. It does say to assemble it all now, but I think we'd be foolish to assemble it without testing. So here goes. And we have nothing. That's not a good sign, is it? Oh, here we go. Ah, battery wasn't in properly. Right. Okay. That's a relief. The battery just wasn't clicked into the holder. So it's on that one. So we press it and it goes round and stops. Or we shake it and it goes round and stops at some random point. I think the randomness is added by the user. So I think if I press that and hold it, it will carry on going indefinitely. And then when I let go, one of these capacitors is charging or discharging, which is getting it to the stop point. It would be interesting just to do a blindfolded press, wait, and actually see if there's any bias in this device. But there we go, it's working. So now I think we've got to put that in the box. I'll take the batteries out for now. And we need to assemble the case. So for this, I will try to follow the instructions. I'll need the screwdriver or something. So there's all the parts. We do need to peel some film off, I think it says, yeah. Is there film on these? Or is that just a surface texture? I don't know if there is. It is film. Okay, well, I suppose we'll take it off then. Yeah, it's very definitely fused there. I can see that this is lifted up a little bit, but it's still also like attached to the edge of the plastic. Yeah, top side of the piece is much easier to come off. Oh well, nearly there. Right, so assembly of the case. So we are to put these little standoffs all right, we put those standoffs into those standoffs. On each corner. The front case on with screws. Which doesn't go. Are there longer and shorter screws? No, it doesn't go. Now it must be I've got the standoffs the wrong way around. Okay, right, let's try that again. So now this, yeah, it does get close enough to these screws that we can screw them in. Be careful how tight we tighten those up because it's going through acrylic. Okay, and these side panels go in, and we're going to have to try to hold all four of these in at the same time. Where are the other two gone? There. Right, that cable has to come across the back there. Hang on a minute, have I got to stick this battery pack on first? No, just got to thread it through there, I think. Fortunately, there is enough room for those wires to go round the side there. That was a thing I was concerned about. Then this bit slots onto there and holds those captive, like so. And then we put the other four screws in. Are these sides all the same? Hang on a minute. Are there too short and too long sides here? There are. That's why they're not all the same. So we've got too short and too long sides. So not make well. Maybe that text there is telling me about that, but it's not abundantly clear. Right. Okay. Let's try that again then. So short side there. Short side, long sides here, because the corners were interfering with each other. So that's it. Another long side here, and then short side here. And the long side's fallen out, so we'll have to put that back. That's better. Right, I'll get the screw in the other corner, and that will hopefully stop that from disassembling itself. Well, that's weird, because that button is not aligned with the top panel. That's weird. So this top panel, that hole is supposed to be aligned with that button. I wonder if this top panel has a specific orientation then. Okay, let's just try that the other way around then, like that, or like that. Yeah, it's actually quite specific where that, while I'm here, I ought to, so it's got to go that way around. So that top panel does have a specific orientation. How about that? Slightly surprising, but I would have thought they would have just made it so that it was 4 identical sides and corners, but there it is anyway. I imagine that could be a point of frustration for anybody doing this kit, is obviously if you can read this, if you can read the language, then no problem. I suppose I could have used my phone to translate the printing here. So that might also work, although machine translation is not always very reliable. But yeah, that could be a point of frustration really, because that case is not as simple to assemble as it might first seem. Right, and then I think we have to stick that battery compartment in there. So we just have to, does it go inside? It does. So I'm going to have to coil these wires around in there, like that. Maybe I should have assembled that bit before anything else. But anyway, we're here now. Right, so that sticky pad comes off, or the backing does. And then that somehow goes into there. Something like that. Okay. I mean, it's weird that the battery isn't completely contained, but it is what it is. Can't complain really. It was very, very cheap, this kit. So have I managed to kill it in the process here, or have I just not got it connected again? Yeah, battery terminal's a bit iffy. There it is. There is the finished thing. And we can shake it. Now the only slight problem is you can't see the number 10 there because I've put the wires over the top of it. So I suppose I could just go in there and try and move those. There we go. So there we go, a random number device which will select, and if I keep on shaking it, it will keep on going around. You're going to actually stop? Okay, well we seem to have hit on another problem there then. I wonder if it's... Oh, I see. That little tilt switch thing is a tilt switch. So if it's tilted that way, it will just keep on going around forever. Okay. It's not perfect. We don't live in a perfect world. Well, there we are. That was fun. Frustrating at times, but also fun. Good practice soldering. Not a bad little project, really. And it works. So I don't think I will do the other one in this video. I think we might do a part 2 where I'll assemble this one, because that's already been quite a long video. So anyway, there we go. That's my little random number kit thing from Aliexpress, which I just bought to top up the price of an order, so I wouldn't have to pay shipping. One interesting and possibly unintended bonus feature of this device is if I stand it up like that, because that tilt switch is activated, it'll just carry on doing that indefinitely. So I suppose there's a little widget I can put on the shelf when I'm doing my videos in the studio, and we can have a few more blinking lights behind. I hope that's been interesting. Thanks for watching, and I hope to see you again soon.